10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Good morning, everybody. Welcome back to day 3 of Yacht Engineering Week 2021. We're here at Lauderdale Marine Center. I'm back with Heather Lee.
Yes, we have had 2 full educational days, as always, and it's only day 3. I cannot wait to see what else we have in store this week, Paul.
Well, there's a lot more to see. Yesterday afternoon, after we got done with Malcolm, we had the opportunity to catch up with Rich Marriage at AME.
Yes, let's see what we learned.
All righty then. Good morning, everybody, and welcome back. Let's get this day started. We're at AME Solutions with Rich Marriage. Good morning, Rich.
Good morning. How you doing?
Really well, thanks. Nice to have you back here.
Pleasure.
Rich is with us from AME Solutions. AME has been a great contributor to our yacht engineering seminars over the years. In fact, one of our initial sponsors for this event. So one of our greatest consistent contributors. The great thing about AME Solutions is they provide a different product than virtually anybody else out there, and that product is vibration analysis. Rich, give us a little quick overview of what you're able to do to help people through vibration analysis.
Vibration analysis is a very powerful tool for picking up mechanical issues with machinery. So what we do is by taking vibration data we have a database that we've built over the years that standardized places to measure vibration on a hull. We'll typically go on a sea trial and we'll identify points. We have measurement points, and we will go through the boat and measure all the machinery and the hull, and we'll pick up vibration, and we can translate that into whether it's the vessel's got a bent shaft, whether it's got exhaust issues, engine mount problems, misfire, and so on. So we're able to get a pretty good, accurate diagnosis, so you don't have to chase your tail and try to find a problem.
So on 2 different fronts. 1, it's a comfort level, and 2, it's a longevity and maintenance issue.
Correct.
That you guys are able to deal with.
Yeah.
So last year, what we did is we were on a custom sport fishing boat, and the application was a different engine mount system. And you guys were able to identify through your vibration analysis equipment that something that they had done over and over, they had to do differently on a custom boat. Yeah. And lo and behold, they did it the same way they always did and thought it worked. Yeah. And we identified the issue. Yep. The great news is we identified what the issue was, what the fix was, and you showed us not only through, I believe it was your RDI equipment for the analysis, we also showed everybody how we laser target the gear to make sure that everything was aligned perfectly.
Exactly. We used we have this really cool technology. It's using video motion amplification. Okay. And from the video, we're able to pinpoint we'll video an object, and we can actually pinpoint vibration on that, pick out a pixel, get a vibration frequency and amplitude, and we're able to clearly identify problems.
By going back through your references, you're able to tell where that issue, where the issue lies.
And the beauty of it is you can see it. So seeing is believing. By amplifying the motion, you can show a customer what their problem is, and they can see it with their own eyes.
Perfect. So one of the great things that we have the ability to do here also is to go out into the yard and see how this stuff actually works. We're going to cut down to Heather and Chris in the yard underneath one of the boats. Chris has set up some of the equipment, and Heather's going to ask him how it works, and he's going to show her what value that equipment has in identifying issues that you may not even think would be an issue.
All right, we are here in the yard, and I want to tell you in advance, it is a working yard, so if there's any noises, if it gets a little noisy, bear with us. But I'm here with Chris at AME. He's one of the lead engineers, and today he's going to perform a bump test for us. So let's go find out what that even means. Hey, Chris.
Hey, how you doing?
Good, good. So you're going to show us today how to do a bump test, but first, tell our viewers what does that mean?
All right, so bump test, what is that? That's essentially, it can mean a lot of things, but we're working at the struts here today. Actually, let me turn on this light, and you can see these struts that we're working with. So this is where the shaft line sits. You got your propeller shaft, and then you got your propeller. And a lot of our vibration that it's pretty common is, in the whole structure, you feel the shaft rate and the propeller blade pass rate. And that is transmitted typically through the struts. And what excites this vibration is the looseness of the strut, which can amplify the vibration. And depending on our vibration analysis, which we normally conduct when before the vessel gets hauled out, we go out to the landing, we do a certain speed or a variety of speeds, and we'll do data collection around the machinery, the gearbox, and then shaft line, and various points of the whole structure. And based on our report, we'll do analysis and see that the shaft rate or propeller blade pass rate is excessive. So we'll look into this. Once it's hauled out, we'll set up with our RDI system here, which consists of our computer, RDI camera, and our nice light here. We'll use this to do this bump test. So this bump test will determine the natural frequency of the struts themselves, which inherently give us the stiffness of the struts.
Okay, so a bump test, it is what it sounds like. You bump it and you see how much it moves.
Exactly.
To dumb it down to a very kindergarten level, that's essentially what it is. Okay, perfect.
So yeah, we're just bumping it and then just watching it and see what it does, and then after that we'll go from there and make a report with our conclusions and what we recommend.
Okay, so let's bump it.
All right, I'll set this up real quick. I'll put the light here. So we need this light to get the camera lens here. So this is
what we're looking at. Okay.
Yeah, so I'll give you the actual mallet, and you'll go.
All right, I'm ready. Okay, where should I hit it? Right in the middle?
Yeah, right there.
Okay. All right, tell me when.
All right, 3, 2, 1. Very nice.
All right. Let's take a look.
Here. We'll take a look at the vibration. We'll export it. Let the software do its,
thing. Okay.
So actually, let's bring it down. No amplification.
Okay.
But in fair, this is a pretty strut configuration with the attached to the heel here. So it doesn't move at all.
Okay. Now let's amp it up. Let's see if it moves. Maybe it'll move a little. It looks pretty rigid to me. Or maybe I'm just weak. Who knows?
No, you're standing up to a couple of, almost 100-ton vessel here, so.
All right.
It's in fairness.
Fair enough.
You gave it a good hit.
Thank you.
So, actually now we'll go.
Let's try this one.
Yeah.
I'll let you take a swing this time. How about that?
I'll give you the computer here.
I'll trade you here.
And actually.
Show me what to do.
So we'll open up the camera software again.
Okay.
And then I'll adjust the camera here itself. That's a pretty good view.
Pretty good.
So that's all we want. We want a good view of it.
And I just press record?
Yeah, just press record.
Okay.
Do this. So this is the eye strut. So you see the two different configurations.
Yes.
But this is the eye strut. It's typically, in most of these custom yachts, this is the configuration. You see the V strut or eye strut. And these are more prone to being a little bit weaker.
Okay. All right, let's take a look. I'll give you a 3, 2, 1.
All right.
Okay, 3, 2, 1. Okay. Yeah, you can hear that one.
All right, so I'll take
Okay.
this for you. We'll export it here. So we'll do non-amplified. And hit it. Doesn't look like anything.
It looks like it doesn't move.
And then you really see it moving.
Oh, wow.
Yeah, we can do that again. In case you missed it. Yeah.
Oh, wow.
So this, in essence, this is actually not very bad. We have a lot of data on if you're using this camera, and we've found a lot of issues with struts in the past.
Okay.
And we have, if we could probably share some of these videos with you and.
Sure. Yeah, so now to the naked eye, you don't see it, but once you amplify the vibrations, that's where you see
Exactly.
the issue.
So, and that's where we kind of convey it. You know, we found the issue, and we want to, you know, show it to the customer and say, here, this is the issue. You know, your vibration is being excited by this, and you know, to resolve, you know, the vibration that you're feeling, this is where you want to start, and that's really helps narrow it down and convey, you know, to people who don't really stand the vibration and, you know, like numbers on a graph. This really shows you, yes, it's vibrating.
Yes,
It
no, you
shouldn't
can
be, so.
you can see it, of course. So now we've identified the issue, but how do we get to the issue? Is it manufacturer error, user error, combination? You know, no one's perfect.
Exactly, yes. No one's perfect. So I mean, these vessels are normally operated, you know, like shallow water. So I mean, you'll have a combination of, you know, manufacturing defects, which, like, I mean, port and start, you got 2 struts, sometimes 4 struts like this one does, an intermediate and a half strut. And you got that on both sides. So sometimes, you know, going from one side to the next, it's not exactly the same. So you have a little bit difference, and sometimes that difference isn't, you know, for the better. So
Right.
so that's from the manufacturing defect side. If there is any, it's very rare. Some more common would be like human error, like you're saying, is, you know, in these shallow waters, you know, touching the bottom, you could either, you know, weaken the strut, you know, a little structural damage, or, you know, bend the strut. And this really shows, you know, what's happened. So we can also do this, you know, once we repair the strut, we'll do this video, and then, you know, a video of it, you know, fixed, and shows it, you know, not moving, and, you know, the improvement. So that's the other nice thing. You can actually see improvements. You can see, you know, the root cause and, you know, the conclusion of.
That's great. So you do the bump test before and after to
Exactly.
show the progress.
Yes.
Wow, that's great.
So, I mean, we could do some more today. There's a lot of things you can check with this camera, which is great. It's very useful. I mean, it's very, you know, compact. You literally just set it up wherever you want to do your findings, and you just shoot it, diagnose it, and send out the report. So.
Awesome. Well, I'll be honest with you, I didn't think I'd be hitting struts with the mallet today, but that was pretty fun.
Yeah, you never know.
But it is pretty noisy out here, so we're going to throw it back to you, Paul. Thank you, Chris.
Thank you.
Thanks very much, Heather. So there was a pleasure boat application again. Last year we talked about a custom sport fishing boat. Here we looked at the bump test on a motor yacht to identify an issue on a pleasure boat that maybe you wouldn't have even thought of. So not only pleasure boat applications for AME to do vibration analysis, but there's also a lot of commercial application for that. We're back up with Rich and Tony, and we're going to talk about, Rich, if I'm not mistaken, you guys had a commercial boat application all the way up in Dutch Harbor, Alaska, didn't you?
Yeah, it was pretty cool. We were up in, get it? Cool. It was Dutch Harbor, Alaska, and it was a commercial fishing boat, large vessel.
Okay.
It's a fish factory trawler.
Okay.
And they were experiencing, they have, the way the propulsion system on this vessel is arranged is they have 5 diesel electric generators driving electric motors which drive Z-drive propulsion.
Okay.
And what was happening was they were losing the electric generators, the torsional couplings between the generator and the engine was failing, and we were there to troubleshoot and diagnose that problem.
So they were losing their main propulsion system in potentially very, very deadly situations.
Yes, the chief engineer had told us that they actually lost propulsion. They lost some of the generators when they were in a 30-foot seas, and he said they can't afford that. that could be deadly.
Absolutely, that's an incredibly dangerous situation. So what you guys were able to do was to employ your equipment to identify a vibration that was causing this problem?
Exactly. And I can have Tony speak more about that. Tony's one of our lead engineers, and he worked together with Chris. Chris was in the field, and he and Tony were involved in analyzing the data and coming up with a solution.
Very cool. So I think, if I'm not mistaken, Tony, you've got a video that you could walk us through that shows us a little bit about what was going on and how you set up and how you identified.
Yeah, absolutely.
I'll tee to you.
Play it right now.
All right, let me sneak by you here so you can show Paul what's going on the screen.
So like you guys saw with Chris and Heather downstairs, this is the setup with the camera. This is the engine room with the generators. And then it kind of goes right into just giving us a snippet of what's going on. And I actually have this source file that I'm going to play next.
Right here is your amplified video.
So that was the key thing that we kind of honed in on right away, is that motion in the frame. So that frame was distorting and was essentially overloading those torsional couplings.
So the engine itself was moving more than the torsional coupling was allowing for.
Yeah,
exactly.
Okay, so it was overloading that coupling.
Yeah.
Okay.
All right.
Now, was that something that you could see with the naked eye, or you couldn't see that until you put the equipment on?
So if you paid attention to that, I'll run this video back real quick.
Okay.
So this actually shows you the live video right here. So this is what it looks like to the naked eye.
Okay.
And then this is what the software is picking up here.
Okay.
So essentially what it does, it's a high-speed, high-resolution camera that uses the pixels in the camera itself as individual sensors.
Wow, okay.
Yeah, and what it does is it detects the difference in light. And that difference, it essentially, as it is aptly named, amplifies that motion.
So the software itself
Correct.
takes the video apart and and amplifies what's going on in the video so that you can see with the naked eye what you couldn't see.
Correct.
Okay.
Yeah.
Or you can see in the video what you couldn't see with the naked eye.
Right.
Okay.
Yes.
All right. And there are 5 generators. This is generator number 4. I think you mentioned that was the one that was giving the biggest issue. So they used that as the test case. And then didn't you say that they actually had to do all 5 of the generators, right?
They made our recommended solution. They improvised, or they implemented it on every generator.
Okay.
But this was the one that was troubleshot and diagnosed.
Okay.
And then that was again implemented on all of them.
Okay.
So like I said before, this is the actual feed from the video software. So you look right here, this is what we honed in on. This brace right here was not providing enough
rigidity
and stiffness.
Yeah.
So you can see this is the whole skid for the engine, the diesel generator.
The whole engine mount system.
So the whole skid is twisting.
Okay.
And that essentially was overloading the torsional coupling in the engine,
Okay.
causing it to fail.
So did you engineer the solution for that as well after having identified the issue?
Yes. We created an engine bracket that stiffened right here, this area, and we essentially added multiple gussets, so just support structure essentially, and that stiffened the entire structure.
Okay. So you were able to distribute the load more effectively, stiffen up the whole mount.
Correct.
And remove that element of vibration so that the torsional coupling could do its job, because never will it be 100% true. There's always going to be a slight amount of movement, because that's by the virtue of the fact that it's machinery, right?
Absolutely, especially with diesel engines, it's just so much dynamic motion happening. That is what the torsional coupling is there for.
So what you guys do is not only identify what the issue is, but you're able to come up with the engineered solution. It's not that you just say, hey, here's the problem, call somebody who can fix it. You identify the problem, and through your engineering background, Rich, I guess what you do is you go back in to say, all right, here's where the movement is, here's what we believe the issue is, here's what we believe the solution would be, and you implement that solution as well.
That's correct. One of the things that when I started the company 30 years ago was always my goal was not just to tell people what their problems were, but to actually find a solution to their problem in the machinery world. And it's always been our, what we were all about.
Gotcha.
Yeah.
Gotcha. That's amazing. So, in a commercial application in Dutch Harbor, you guys basically made it safe for these guys to go offshore again and put the boat back to work, where they probably didn't even realize how much danger they were in until they had that catastrophic failure and lost propulsion.
That's correct. And one other thing that we did here that we didn't discuss is we actually laser aligned the generator to the engine as well. So the machinery, we corrected the structural issue and the rigidity of the foundations, but then we followed on with a laser alignment. A precision alignment is always key.
Well, sure it is. As we know from our pleasure boat applications that we're all used to seeing, it's alignment between the engine, the shaft, the struts, the whole drive line. And that's the part that you guys are most known for here in South Florida, is your ability to analyze alignment issues and correct them.
Right.
But here's a completely different application, and where that really makes sense is today we're moving more towards hybrid propulsion systems in the boats. And you're seeing a whole lot more EPA pressure, you're seeing a whole lot more IMO pressure, you're seeing compliance issues.
Yes.
And I mean, there are even automobile manufacturers who are announcing right now that they'll no longer produce internal combustion automobiles as of 2035. Well, it's only natural that that will go downstream into the marine industry.
Yeah.
Plus the fact that we're very sensitive to what's going on in the environment through boating. And while we love our pleasures, we want to do it responsibly. So the reality of it is we'll see more of these diesel electric applications in a pleasure boat marketplace. And it's not just aligning an engine to a shaft anymore. You actually have to align any and all pieces of equipment that you're operating.
I agree.
So the generator being driven by a propulsion engine, even our self-contained units that we use right now, be they from Northern Lights or Westerbeek or Kohler or Caterpillar or whomever, we're pulling power from them to drive these drives, but we're going to see more advanced and more commercial style applications in probably a lot of these big boats that are coming out of Europe.
I agree. I think the future, this electric propulsion is the beginning of a shift from direct drive to more electric-driven propulsion.
And I would have to think, while there's a lot of talk about hydrogen, the challenge with hydrogen as a propulsion system is going to be sourcing the hydrogen itself, storing the hydrogen itself, and developing the new technologies for hydrogen burning engines. So this is probably a much more logical, forward-looking solution to our propulsion issues.
Well, not to get off track here, but one other thing. We recently were involved in sea trials and commissioning sea trials on the LNG bunkering vessel that was built down in Texas.
Okay.
So so what they're doing is they're using LNG. They built a integrated tug barge that is using LNG on the main engine and on the tug part of it, and they have a barge with LNG tanks that they're going to use to bunker the cruise ships.
Okay.
So this vessel was built specifically for the future for bunkering LNG, which is the next, LNG starting
Liquid
to come
natural
in
gas.
because it's a pretty easy transition for a diesel to make it run on LNG.
Okay.
So that seems to be the next step. And then I can foresee where hydrogen will probably be the next
Coming
one
behind
after that.
Okay.
Once they go through but LNG is a very clean burning fuel, so apparently that's pretty good. And this bunkering ship was quite sophisticated.
But anytime you've got rotation, you've got a potential for vibration.
Yeah,
And there's an engineering solution if there's a vibration.
that's right.
But you got to find out where it is and what's causing it first.
You always got to find your problem first, right?
Before you can
Before you
identify
can-
your solution.
Exactly.
Absolutely. That's going to wrap up our segment at AME. Guys, thanks again very much for not only your continued support, but always wonderful information and things that we don't normally think about on the boat, but important considerations to comfort and to safety.
Thank you, Paul, and we really appreciate your support and the support of EBA.
Well, we appreciate that. We're going to wrap it up for this segment. We're going to break for a commercial, and then we'll be back with more.
Yacht Engineering Week 2021 has been made possible by Pantropic Power, the only authorized Caterpillar Power Systems dealer in South Florida. Florida Nautical Surveyors, your complete solution to all of your vessel surveying needs. And Robert Allen Law, exclusively dealing with the business of yachting. We would also like to thank Quantum Stabilizers, AME Solutions, DeAngelo Exhaust, MPI Marine Professionals Incorporated, Concord Marine Electronics, Lauderdale Marine Center, Marine Data, Isotropic, Dockmate, and Murray Ventilation Products. We'll be right back.
For most of us, working with our passion is nothing more than a dream. But for Edward Cattell, it's life.
When I was growing up in the 1960s, when I was riding my bicycle home every day to and from school, I would collect bottles. And the bottles were worth 5, 10, 15 cents or whatever. I'd collect them. I saved up enough bottles to buy a little boat. So that was my first boat. The kids in the neighborhood, we all loved to fish. We'd ride our bikes to the nearest marina or docks. We'd fish all day long. We loved it, we loved it, we loved it.
In high school, Ed started catching his own lobsters and selling them by the side of the road. His childhood dream of one day making a living at sea was becoming a reality.
My parents really didn't want me to go that way. They wanted me to become a businessman, and finally they gave in, and I got an opportunity.
Ed started out as a young mate at Pantropic. Little did he know that 12 years later, he would become the captain of the whole operation.
They've supported me and encouraged me and mentored me, and it's been a great experience. I get the best job in the company, they always tell me, which is true.
After a lifetime at sea, Ed still enjoys every moment of the job. And even in his spare time, he loves spending his days on the water. For Ed, the Cool Cat is more than a boat. She's family.
So Paul, I know you were up in Stewart the other day learning about air inlet filtration.
I was, yeah. Mike Murray at Murray Ventilation Products was kind enough to give us a real good rundown on everything you need to know about getting clean air into the engine room. Let's cut away to that. All right, welcome back everybody. We were in Fort Lauderdale for that last segment, and we're in Stewart, Florida at Murray Ventilation Products for this segment. We're here with Mike Murray at Murray Ventilation. How you doing, Mike?
I'm good. How are you today?
Really well, thanks. And
Good.
Thanks for having us here.
It's a pleasure to have you.
Our conversation today is about air inlet filtration and air circulation, primarily through engine spaces. So it's kind of one of those things, Mike, that people take for granted. It's I guess a design element that the naval architect inputs into the design of the boat, and the brokerage community, the sales community, even the repair and refit community doesn't really think twice about it.
No. And in truth, the truth be told, it doesn't really affect the mission of the boat, whether it be a fishing boat or a pleasure yacht or a commercial vessel or anything, unless it results in the breakdown of machinery.
Well, and that's the key here is the machinery is not going to operate properly unless we have a balanced airflow. The key to that is having clean air, and one of the things that we've learned in the last several years is the ability to remove the moisture from that air as it comes into the engine room. So there are two components that we're going to talk about here in this segment. One is the filtering the air when we bring it in, and one is the circulating of air and what the purposes of those two systems are. Let's take a look over here. We got a couple of exhaust fans, or are they inlet fans?
Well, there's one of each actually. This is
okay.
To so what you were just speaking about.
The air comes in, the air goes out.
These are a set of fans that are going in a yacht.
Okay.
That gets its engine combustion air naturally. So in other words, open louver vent, the air for the engine is provided naturally to the turbos without any aid of fans.
So it's just ambient, it's not pressurized.
Correct.
Okay.
So it'll actually make a slight negative pressure.
Okay.
But again, we size the openings to make sure that we don't have undue pressure losses so the engines aren't starving. So these fans are going to provide an air current in and out to maintain a certain temperature in the engine room so that the engines don't derate, so your electronic equipment doesn't derate, and you don't have big failures.
So there are a couple of principles that I think I'd like to speak about with regard to all this. Number one, any of us that have been around the industry for a while, we've walked on board a boat and gone down in the companionway, and we've seen black soot around the carpet at the engine, at the bilge hatches.
Yep.
Why is that? How does that happen? What's
well,
that about?
It turns out Berber makes a great filter.
So
what's happening
I don't think
there?
That was the idea.
No, not the intention. So what's happening there is there's insufficient air openings for the engines to pull air from the exterior. And what happens then is you wind up pulling through a salon door or through a hatch or through some other spot, and then you couple that with a little station wagon effect with a little bit of exhaust behind the boat, and the engines, which by the way, they will get their air. They can pull a lot of vacuum. They pull through the salon door, they pull through hatches, and it winds its way through the living spaces down in, and then the soot gets caught in a carpet, and you wind up with a perfect outline of the soft patch or the hatch underneath the carpet. So.
Okay, so the first thing that we got to consider is we've got to have the proper amount of air, because an engine is basically an air pump. Air in, air out, combustion creating that movement. So was there a rule of thumb? Was there any, how did they figure this out in years past when they first started doing?
Rule of thumb is exactly what pretty much all the engine manufacturers back in the day, and unfortunately still to this day would say so many square inches per horsepower, but it really doesn't take into consideration different displacement engines and so forth. However, engine manufacturers also provide empirical data saying this engine at this horsepower at 100% load consumes this many cubic meters per hour or cubic feet per minute, and that gives us the exact point at 100% load what that engine requires.
Okay.
So hopefully people aren't going to operate like that too often unless you have an emergency and you have to get home.
Right.
So we try to design for that scenario from a new build standpoint. Unfortunately, with refits, we can't often get to that. So
refit brings in a completely different element, because what we also find in today's marketplace is that there's different horsepower available in smaller footprints and in lighter components. So people are, let's say we take a pair of 1271s out, well, we'll replace those with an inline 6-cylinder Caterpillar, as an example, and you've got a much smaller engine that's lighter but developing the same amount of horsepower. Is it requiring more air? Is it requiring different flows?
Sometimes yes, sometimes no.
Okay.
And then again, depending on which manufacturer you use, some engines are a little bit hotter running than others.
Okay.
Some engines have more jacket water cooling, so they're a little bit cooler.
Okay.
But we have to look at each one on a case by case. And then what we do here is we do an analysis based on the specific boat that we're working on.
Okay.
How much air do we require for combustion? How much cooling air should we have through the space to go back out? And then try to balance that.
Let's talk for a quick second about the cooling air component of it. What we've been talking about to this point has been combustion air, needing to have a certain amount of air, unrestricted flow, properly filtered into the engine compartment in order to have the engine run efficiently and combust properly. What other components and considerations do we have in the engine room that we have to think about with ventilation air?
Sure. So in addition to consuming air, which varies with RPM, the engine will get to temperature. Your engines will get to temperature. Your generator will get to temperature, and then also there's other equipment if you have
exhaust manifold gets to a high temperature.
You could have compressors in there that generate heat. You can have a power transformer, which admittedly won't be running while you're running, but that'll generate heat. So all these things need to be taken into consideration as heat sources. And again, data is available for radiated heat, whether it be in kilowatts or BTUs per minute. And then what we do here is we do a thermodynamic analysis on that.
Okay.
Assume, unless we're in the Middle East, 95 degrees or 35 C ambient, And then the engine manufacturer's machinery specification will call out what their ceiling is, whether it's 50C or 122 degrees or somewhere in there in that range. So we try to maintain that differential, between that differential, so that everything in the engine room is happy. So we do that by, you do a thermodynamic analysis, it comes up with a volume of air we need.
Okay.
So we have a volume of air that needs to be passed through there and removed, not just circulated.
Right.
It's the old pot of boiling water thing. You can stir it up, it'll just all be hot. So air has to be introduced and removed for cooling in order for it to be efficient.
Well, and that's, you mentioned the pot of boiling water, and that's very interesting because most people don't think about the fact that air is fluid. Air is a fluid. It has a flow, a current, disruptions.
Absolutely.
There's turbulent, there's laminar flow. There are a lot of different ways that we can move air around. And what we want to do is we want to make it efficient. We want to introduce the proper amount that we need, but not too much.
Right.
Because if we introduce too much, then that creates other problems on the other end of the spectrum, right?
Absolutely.
Okay.
Absolutely.
Plus having to have much bigger holes than we need in order to allow that
Oh,
air
absolutely.
in.
I mean, there's a number of things. So you've got expense, bigger equipment, you've got power consumption, and you've got
Structural
real estate, you've
considerations.
got physical, weight constraints and actual size of equipment. So
Right.
it's very important to size things as best as possible.
So the first thing that we looked at, just coincidentally, was inlet and exhaust fan housings that will enhance circulation of the air.
Correct.
So let's take a look at a louver that gives you the ability to shut off the airflow or open the airflow, and then we can take a look at the science behind how we remove the moisture from the air, because that's the secret sauce that didn't exist in years past.
Yep. So these products that we have here, this is what we call it is a fire damper. Now this is an aluminum fire damper that's been powder coated. You can see a frame here we're in the middle of construction, so we prep this to get powder coated and then send it out. We do that solely for the purpose of the fact that we are a marine manufacturer and raw materials aren't going to last as good. This is a better product for us, for our clients.
So fire damper, is that a requirement under
It
code?
is depending on the classification of the boat.
Okay.
So the most stringent would be an A60 requirement, which this damper does not meet. We do sell A60 dampers. They're stainless steel.
Okay.
And what A60 means is it's a fire test where they burn a furnace at, I believe it's 1760 F for an hour.
Okay.
And the damper has to maintain a temperature differential as well as integrity without failing.
So in the event that you have a fire,
that'll close. Yep. Now this will close with this actuator. So what this is an electric actuator. This one happens to be 24 volts.
Okay.
So the way this becomes fail-safe, and this ties in with the fire system on the boat, is that this damper is held open with power.
Okay.
And it's a fraction of an amp to hold it open.
Okay.
So this actuator is tied in with the fire system.
Okay.
So when the fire system discharges, it opens the circuit, cuts the power, and this damper will spring closed.
Slaps closed.
And stay closed.
Okay.
Yeah.
All right. Thereby preventing the fire from getting through.
Correct.
Okay.
Correct. So that this is something. I have also seen situations where we had a boat, which we always talk about heat. We had a boat in the Arctic that wanted to keep the heat in the engine room.
Capture the heat.
So
Sure.
we were able to put we were able to make a custom control where they could close the dampers and keep them closed
capture
to
the
try
heat.
to maintain a little bit of heat.
So it was thermostatically
Well, what we did
controlled.
there also is we also had a safety there where they couldn't start the engines with the dampers shut.
Okay.
Because that would be a really bad thing.
Yeah, you kind of want that air.
Absolutely. So,
Yeah.
so anyhow, so these are fire dampers. That's really their only purpose.
Okay.
We see almost all the bigger yachts and even some production boats are putting them on. It's good practice.
Okay.
Certain classifications will allow them not to have them, but then the fire bottle, the fire system has to be oversized to allow for leakage.
Okay.
So that's the skinny on that.
So that's the damper itself.
Yep, that's a fire damper.
So let's
So
go.
the first line of defense
Right.
is the moist air being drawn in.
Okay.
So we want to stop the moisture. We want to stop the salt droplets from getting through there and making their way to a turbo intake, so that your air sep filter is just for dust and not
Right.
trying to stop water. Because
Right.
at that point, very often it's too late. You've been in the business forever, and we've seen some pretty catastrophic failures
Yeah,
as a result of
I've
that.
seen a few messes.
Yeah,
Absolutely.
yeah.
And
So-
that's interesting that you mentioned that, because air sep is the piece that is probably the most famous around the industry
Sure.
as the newer technology, even though it's been probably 40 years now, that filters the air going into the engine.
Right.
But what we want to do is we want to filter the air before it ever enters the engine room.
Correct.
Because of all the other components
Correct.
that are in there, not to mention just the engine.
A catastrophic failure in your main engine is awful. However, more and more now we have so much ancillary equipment in the
Right.
engine room, electronic equipment, and having moist salt air in there is just awful.
It's a bad thing.
Awful, awful. Yeah.
So let's take a look at what we would call our air inlet filter
Sure.
system. And these are hull side vents, if I'm not mistaken.
These
right?
are, yeah. These
Okay.
are actually, what this is pretty interesting project. This is a 1986 54 Bertram.
Okay, so talk about refits.
Sure. So Bertram used to have what, you've been on Bertrams with 54s. We've
I was
all
on
been
86 54s
Yeah.
when they were new.
Caught my first Blue Marlin on one of those,
There
as many
you
people
go.
did. So they had hull topside cowlings
Scoops,
that
yeah.
used to take your toenails off when you walked up the gunnels,
Got
and
the
a,
scars
and a
to prove
small rectangular opening for combustion
Right.
air.
Okay.
So this is a customer that wanted to modernize this boat,
Okay.
because now we do supply Bertram presently with their ventilation. So
Okay.
they got us. Bertram got him in touch with me, and I went out to the boat, and he wanted to modernize the boat and make it look a little better. So what this is actually it's two things here. We have a grill, and this is really just for aesthetics.
Okay.
So this grill, this horizontal grill you see, is going to be seen on the side of the hull.
So to know in the side of a 54 Bertram has the step. This is the port side of the boat.
This will be port
there's
side,
your
yep.
gunnel.
Mhm.
There's where it steps down, and then there's your cockpit gunnel
Yeah,
going
that's
aft.
correct. So
Okay,
this
is the
angle,
forward.
to aft, this angle matches the rub rail.
Okay.
And then this angle matches the broken shear on the old 54 Bertram. So
Okay.
this, rather than a rectangular opening, this is a much more aesthetically pleasing.
It looks like it belongs.
Yeah. However, keeping in mind function. So we have enough open area here to feed the engines in this boat.
Okay.
Okay. But behind it, and it's hidden, is this back louver, which is a mist eliminator. So
Okay.
this is a series of louvers that
right.
forces the air to turn hard, first forward and then aft, with hooks in. And I'll show you a sample of what that is in a second.
Okay.
To stop the water.
Okay.
So this is actually the bottom. So this would be sitting in the hull like this.
Right.
And if you put this upright, you'll see that the bottom of this box is angled. And the reason for that is once it catches the water, it slides the water forward. There's a space here where that's open, and the water ejects right back out
Allows
the
the
whole
water
side.
to drop right out.
Correct.
Okay.
Correct. So there's no plumbing, no filters, no maintenance. This gets installed. This will be painted. This is PVC board, which holds paint very, very well.
Okay.
It'll look fantastic, like it was built on the boat. And happy days, they go on, and they have a louver that's sized correctly.
It's a maintenance-free
functions.
item.
Maintenance-free.
Okay. So you install it, you paint it, you
Paint
install
it,
and it
That's-
does its job.
And that's the end of it.
Okay, no
Correct.
moving parts, no
Correct.
nothing to deal with
Correct.
after the fact. We've got a better view of, you were talking about the veins in there.
Correct.
And you said that the water, the air with the water in it will hit the filter and then it eliminates the moisture.
That's right.
Explain to me a little bit about how that works,
Okay.
because it's not intuitive.
So that product we just looked at is mounted on the exterior of the hull.
Okay.
This one would be mounted in the engine room from inside the engine room. So the builder, so you'll have a hull vent which they provide,
Right.
and hopefully we get involved with that, with the engineers to,
Sure.
to make sure that the opening is commensurate with the engine package they have.
Okay.
So the air comes in with the water,
Right.
drops down through the salon sole into the engine room, and then the builder builds a plenum box up against the hull, and this will mount in the plenum box from the inside of the engine room.
So
like
in the engine room, that's what you
So
would
you will see this in the engine room, and oftentimes there'll be a damper on the front of it to close it off. But this product right here, like we're looking at right here, you see the louvers are like this,
Well,
and the hooks on the front.
that's what I wanted to understand.
Right. So this is a port side,
Okay.
like so. So what you see here is the air is going to be coming from this side,
Okay.
and then as the air is forced to turn, there's
air
a hook
comes in here.
which catches the water.
Okay.
So centrifugal force forces the water, which is heavier, up against the face of this louver.
Okay.
And it slides into this hook and then drops down. And then we have these big drain slots at the bottom to drain the water out of it. And then when it turns the other way, on the back side, it's harder to see, but there's a smaller one here, just in case you have an extremely heavy
little
load
lip.
of water. Yeah.
Okay.
Yeah. But here, let me grab a louver.
Okay.
Oh. Brandon, what did you do with that louver I set over here? I know. Where did it go?
Okay.
Okay, so this is the louver this one is a 3-inch This one is a 4-inch. We also have a 7-inch louver. So
interestingly, if you set this one by this one here, the angle is very different when you get into the smaller one.
Correct.
And
we just developed this smaller louver at the request of some customers that were building some boats that had really, really tight spots, and they still wanted to use these products. So there's always a trade-off. So we have shallower box.
Right, the box is.
However, because of the angular construction and the harder turns, you'll get a little bit higher pressure drop.
Okay.
So there'll be a little bit of loss through it in terms of pressure drop. The 4-inch one has a little less pressure drop because it's a little bit smoother curve, and then there's a 7-inch one which is even smoother.
Okay.
So that has the least pressure drop. However, it occupies more physical space, you know.
But going back to the original comment that we made about the fact that air is a fluid.
Oh, correct.
So if we make the bend less of a bend, then it's going to flow more easily.
It's more laminar when it comes out the other end, and it flows easier. So
and thereby creating less pressure drop from the outside to the inside, which means theoretically, if it's thicker, we could make it a little bit smaller because we still are able to provide the same volume of air inside.
That's correct.
If we're going to have a thin product like this, we theoretically may have to have a little bigger opening.
Right, that's correct.
In order to be able to capture enough air.
So in order for these products to work correctly, there is a range of velocity where they work very, very well.
Okay.
And I mean 99% efficient for droplets to 10 microns.
Wow, okay.
So we want to size, for instance, for this size mist eliminator, somewhere between 650 feet per minute up to about 800 feet per minute if it's natural draft, meaning no fans. So if there's just the engines pulling through, which on a production boat is most often the case. So we try to size this at that size. So at that size, you're looking at a 0.2 inches of water pressure drop, which is imperceptible. You know, for instance, if you're running and you try to open the hatch, you know, you'll feel air when you lift the hatch, but you won't be able, you know, you won't have to fight the hatch to get in there. Yeah. In fact, that's a pretty good indication that you're undersized. If you try to open your engine room hatch and it fights you pretty good, I mean, that's a good layman's way to say, you know, hey, maybe I got to take a look at that.
Or if you go to open the salon door and you can't get it open,
Correct.
you got other issues to look for.
But again, you know, to look at this, you'll see, so the moist air, this will be positioned like this.
Right.
So the moist air comes this way. This would be forward. We try to put the hook forward. The moist air comes in. The air has to turn. The moisture gets slapped against this face between the next louver, which is tied into this, catches the water, it drains out the bottom, and then it either goes
through this open space here.
Correct. And then there's an open space here that goes the other way, and then on the back side of the next louver is a smaller hook, which catches anything that might be left over.
Okay.
And honestly, almost all of it gets caught with this first big hook.
Okay.
And then through the other side is drier air that gets distributed in your engine room and doesn't damage the rest of your equipment. So
right, because your air conditioners, generators, electronic components, battery chargers,
unbelievable amount
all
of
sorts of electrical equipment.
You know, the other thing on a production boat especially is that alley outboard of the engine is most often where you see your ice maker, your AC compressors, all kinds of battery box, all kinds of
directly
equipment
underneath.
Correct.
The air inlet filtration system,
Correct.
or whatever inlet filtration system exists in that particular boat.
So now, when we have these products in conjunction with large axial fans, we can up that velocity up to about 1,300 feet per minute.
Okay.
So we get a smaller area because we're able to pull, because those large fans can withstand a pretty high static loss. So at that velocity, you're looking at about a ½ inch of static there.
Okay.
So which isn't terrible. So the other thing to consider is there's other things that are creating pressure loss in the system. If you have a lot of ducting, you know, there's losses associated with that from friction. Again, there's fluid flow from friction going down that pipe.
Okay.
What kind of duct is it? Is it a flex duct, which is very, very rough?
Or is it smooth?
Or is it smooth? You know, things like that. So these are the things that we design in, you know, we look at prior to saying, okay, you need this. So we engineer it so that we make sure that we're, to the best of our ability, we're able to provide the air coming out in the space is the air that we want. So we can vary fan diameter size, blade pitch, horsepower to make sure that we balance that and overcome that.
So with regard to mist eliminating filters, what we've seen are hull side vents, cabin side vents. Inside of the plenum, we would have a vent. Over the years, I've been on boats that actually drew air in through the cockpit combings, up underneath from the back there. Now, obviously, that's not the preferred way, because we got salt, we've got soot,
Right.
we've got, it's not the cleanest airflow back there. But
Right.
what do we do in the event that we have a boat that we retrofit that has that sort of a system?
The issue there is, again, finding enough real estate, finding enough cross-sectional area
Okay.
to be able to fit this in. You know, today a lot of boats with cockpits have mezzanines, and you can actually use a tow kick and have that void in behind and then mount something like this. You know, there are times when you have to say, this is not attainable, this product won't work. Now the good thing about in a cockpit, there's not as much salt, but there is a lot of soot. There certainly is a lot, especially a big voluminous boat is going to have a lot of station wagon effect.
Sure.
So it's you know, it's something to consider. The worst thing you could do is just fill a hole with a product that's not sized correctly, because eventually you get a velocity so high the water will pass straight through this. Then all you're doing is creating a huge restriction, and you're not doing the job you want to do. So that's the issue there. The other issue is if you have ventilation in your cockpit where you're entertaining, or you're fishing, or whatever you're doing, you introduce noise and heat. So if you're expelling air into the cockpit, you introduce heat and noise right there where you might be, which might not be a big deal when you're running, but when you get dockside and you have to cool the engine space down, now all of a sudden everybody's feet are sweating and you can't hear each other talk because you've got, you know, a fan roaring. So.
Well, that's an interesting point that you bring up as well, because when we're talking about the end of the day, we've got, let's say we've got a motor yacht consideration and we've got exhaust fans. When you shut those motors down, things get pretty hot in the engine room because you don't have the airflow from the boat moving forward. So what solutions are there for that?
Sure, so what we do there is we have a control system which we can fully automate the engine room ventilation system by a number of ways.
We've got a setup over here.
Yeah, there's actually actually a control system that goes with those fans. That this particular one is temperature based only. So what this will do is each fan is wired to a variable frequency drive. And then there's a temperature sensor which will be mounted in the overhead of the space. And then through a PLC, we control the speed of the fans based on the temperature of the engine room, and we can set that. So we have a touch screen. So right now it's on manual, but then we can go to an automatic function, and it says stop. Stop means the engine is stopped. So this is set up so that when the engine is stopped, it won't be an auto, but it has what we call a dock run mode. So the dock run mode will limit the percentage that the fans will run, so that in the event that you do get dockside and then you have to serve cocktails or you're just hanging out in the boat, you don't have this, all of a sudden the only machinery noise are those fans. You don't have engine noise. They can be loud. They can be very loud, absolutely. Especially a high RPM fan can be approaching 100 decibels.
That's
so
loud.
It is. So anyhow, so we can automate this to the point that you don't have to touch it. This senses when there is a ignition, and then when the ignition comes on, the fans go on full automatic and they'll operate to full function. When the boat gets back dockside, it goes to dock mode and it limits it. But what that is a compromise. So rather than shutting down and now you have your machinery space getting super hot, again, electronic equipment is only rated for 40 or 50 C, so you don't want it to get hotter than that because you'll damage electronic equipment, which could get extremely costly. So you're still keeping an airflow through there, again, keeping air coming in, air going out, and eventually when the temperature is reached back to the set point, it shuts down. So what this also does is it ties in with that fire system and the fire dampers. So if there is a fire system discharge, these fans are disabled. So what that does is your fire retardant gets distributed in the engine room. If there's a fire, these fans shut down, the dampers shut, and then that fire is put out. And then only by pushing a bypass mode can you operate again. So it gives you limited access so that you can get home. So there's a safety built in.
The last thing you'd want to do is to discharge the fire repellent or fire retardant and then have it blow right out of there before it gets to do its job.
Well, if at that point, if you've discharged your fire retardant, if it blows up again, you're going to have to abandon ship because now you got a fire you can't stop.
We've had we have a great segment in this week's Yacht Engineering Week about fire retardant with Fire Ranger, and another thing that we talk about this week is exhaust systems. So where it all begins is bringing the air in, and I think we've got a much better understanding of how we bring it in, the importance of having it be dry and clean as it comes in, because it's not just the engines that are using them, but there's so many other things in the engine compartment. And then we also have air that leaves the engine room that's not going out through the exhaust pipes that came through the engine, but has to go out because it's evacuating ambient air that's reducing temperature.
Correct.
Okay.
Correct.
So for temperature control. I think we got a pretty good sense of it, Mike. I really appreciate that. You guys, you've been at this a really long time.
Yep.
If I'm not mistaken, you've been dealing with air inlet filtration for probably, 30 years now?
20 years.
20
After
years?
I retired from being a boat captain. Decided to grow up and use my engineering degree.
Many of us have made that decision, unfortunately.
Yeah.
But it's interesting to see the progress that's been made, the developments have been made.
Sure.
I'm sure there's new stuff on the horizon, but this really does make a big difference.
Yeah, we're constantly developing new stuff. Like, again, we're talking today about big yachts and things like that, but we also develop some products for even center console outboards.
Right.
Everybody's got flat screens now. Everybody's got big booming stereo systems. Very often, all that's housed in a small console. So we have a very simplified DC system that does similar to this with very small fans. So that's coming to the market next for us. But we're always, like I said, we're always looking for a new product. How do we improve what's going on? That product, by the way, can also lend itself to lazarette ventilation.
Okay.
A lot of people are using gyros now,
right?
And if they get put in a lazarette, it's a really bad environment for them because of the moisture. Okay. So what we do there is not only do we deal with temperature, but we add another sensor for humidity. Okay. So the fans come on at very low speed, and they just keep air passing through there. For instance, in our area here, the average springtime humidity in the morning is 83%.
Right.
If you're over 70%, you're going to be developing black mold.
Right.
So that's very difficult. And in the afternoon, it's 60% because the sun burns it off. But in an enclosed space, that moisture stays all day, and it just, I have to tell you, we've all pushed a chamois around and a rag and some spray nine. So
right.
If we can stop that and help the equipment in those areas out, all the better.
There are maintenance issues, and in fact, there are health issues to be considered as well.
Absolutely.
The one thing that I want to wrap up with is in the yachting sector, in the boating sector, we've got a fairly small industry to lean upon for research and development. Are there other areas where you guys cater to provide solutions?
Yes,
do you do military? Do you do commercial?
We do, certainly.
Is that an area that provides us a lot of ability to learn?
And to what you're saying, the commercial and military sectors often drive what the pleasure boat market does. I was talking to one of the engine manufacturers' sales reps one day and was asking, well, why don't we get a new model with a higher horsepower rating? And he said, if we don't have an industrial use for that, you will not see it in the marine market, because, and I couldn't believe this, the marine market represents single-digit percentages of engine sales.
Low single digits.
Very low.
1.5 to 3%.
Absolutely. So we're beholden to that, to the industrial market, to that. Right. And we do anything with a diesel engine or anything where we have some heat transfer. We're glad to service that, but we obviously focus on the marine industry, but there are some industrial aspects, like, for instance, containerized generators, right, which you might see in an oil field, you might see in an oil rig, you could see any. So that's another thing. It's nothing more than it's basically a mobile engine room. Right. It's a diesel engine sitting in a container. It's got to have air coming in for combustion. It's got to have cooling air in, cooling air out. And depending on where it's located, if it's offshore, if it's on a rig, or if it's on deck, then it needs to be conditioned before it gets in. It needs to have that water stop so that the machinery can run.
Excellent. I think that's going to about wrap it up. That's an interesting segment. We're going to break for a commercial, and we'll be back.
Hi, I'm Bob Allen, and I work with a law firm known as Robert Allen Law. We're a law firm dedicated to serving the needs of people in the yacht industry. And that means manufacturers, that means brokers, that means buyers, that means sellers, that means banks, that means people who sell all sorts of things and services to the yacht industry. We're a team of lawyers that has experience in virtually all the fields surrounding this business. And if you're in the business, you know how important it is to work with lawyers who know yachts, right? And know the type of problems that arise and know how to solve them. Our job as lawyers is to help deals get done. Thanks for the opportunity to be of service to the industry, and we look forward to hearing from you if the need arises.
Michael here, founder, Concord Marine Electronics. I've got a lot of customers that ask us how it is we've been in business for over 32 years. And you could take a look at our glowing Google and Facebook reviews for yourself, but our customers tell me they come back because our proposals are so accurate, and our service department is second to none. And on top of that, we've got the technical depth to handle any problems that might come along. We're proud to announce that we've just opened a new location at Lauderdale Marine Center where we're closer to our customers for better service. So when you or your customers are ready for electronic systems completed on time and on budget, call the experts at Concord Marine Electronics.
Dockmate is a small, handheld, wireless remote control for boat operators. It wirelessly controls the boat's engines, thrusters, anchor, and horn to eliminate those difficult docking situations and give boat owners a better boating experience. Our two-way communication between our remote and our receiver provides the redundant safety features owners are looking for. Dockmate is the only wireless remote control that can provide you with smooth, variable, proportional throttle control. Our proprietary customizable software called Dock Control allows us to personalize the Dockmate twist exactly to the owner's specifications. Give yourself a better boating experience and install a Dockmate today on your vessel. DeAngelo Marine Exhaust was founded in a small shop in Fort Lauderdale in 1986. Today, we occupy over 30,000 square feet of state-of-the-art manufacturing and engineering facilities. We produce, service, and repair marine exhaust systems and diesel particulate filter systems. For more information, go to DeAngeloMarine.com. Marine Data Solutions. Our affordable, high-speed internet keeps you connected. Marine Data Solutions is proud to provide superior wireless internet for yachting, 10 times faster than your VSAT at a fraction of the cost. Our unlimited internet service includes no throttle, no contract, no activation fee, no overages, no surprises, and same-day shipping with 24/7 tech support. Check out our Bahamas airtime package, 300 gigabytes for $350, no throttle. And we offer unlimited gigabytes of unthrottled, high-speed mobile internet service throughout the continental United States, a fixed low monthly cost, and no long-term commitment. Call us today to find out more about the best high-speed marine wireless internet. We ship SIMs and equipment anywhere in the world overnight. We are Marine Data Solutions.
And we're back. Heather, I understand you learned a little bit about HVAC.
I did, and before this, all I knew was that HVAC stood for heating, ventilation, and air conditioning.
Well, now you know.
I'm here at Elite Marine Air Conditioning, where Paul has sent me on a special expedition to have a crash course on everything I can learn about air conditioning with Ben Copenhaver. He's waiting for me inside. Nice. Hi Ben, how are you?
Hey Heather, how are you?
Good.
Welcome.
Thank you very much. So Paul has sent me to learn everything I can about air conditioning, and you're the expert, I've heard.
Okay, all right. Well, why don't we talk about the fundamentals first, and then we'll look at some equipment.
Okay, let's do it.
Come on in.
Thank you very much.
So I've queued up just a quick diagram.
Okay.
So every air conditioning system in the world, whether it's on a yacht, a house, a building, they all have 4 major components. And what we're trying to do basically is actually move heat from one space to somewhere else that we don't want it.
Okay.
So every system is going to have a compressor, a condenser, a metering device, and an evaporator. In yachting, we're going to use seawater typically to cool the condenser, and then the evaporator is going to transfer or absorb heat out of the yacht into the refrigerant, and then go back to the compressor, and it just keeps going and going and going.
Okay.
All right? Simple, right?
Seems like it. Let's take a look at an actual unit, though.
Okay.
Do you have some of those here?
Yeah.
Okay.
So why don't I take you over to Southern Marine Supply?
Okay.
And that's where we distribute equipment, and we'll show you some new stuff there.
Okay, great. Beautiful facility you have here.
Thank you. So Southern Marine is where we inventory brand new equipment for Elite Marine as well as other dealers to buy for the local area.
Thank you.
Okay, so there's 3 different types of marine AC systems. They're going to be a self-contained unit. That's going to be for your smaller boats, 30 to 50 feet.
Okay.
And a self-contained unit's going to have all 4 of those major components. Do you remember what they are?
No.
Okay. Compressor, condenser, evaporator, metering device.
That's right.
So everything is self-contained. These are great because they're easier to install. They don't require, you can have your do-it-yourselfers occasionally install those. But there is some compromises. They do make more noise because they're going to be located in the cooled space or the conditioned space. So it could be under the master bedroom, for example, and it's going to make a little bit more noise because the compressor is located inside the cabin.
I see. Okay, so what are the four parts again, and where are they at?
So condenser, this is where
It's
we're
right
going to
Okay.
we're going to remove the heat. We're going to put the heat into the seawater, and that's going to go overboard.
Okay.
The evaporator is where we're going to absorb the heat from the boat, and the compressor is going to circulate the refrigerant, and then the metering device is going to change the refrigerant from a high pressure liquid to a low pressure liquid.
Okay.
Yeah. So
Got
that's
it.
going to be between the condenser and the evaporator.
Okay.
All right.
And then what other types of systems
So
do we have here?
the next type of system is going to be for your mid-range boats, boats 50 to 80 feet. And in this case, they're putting the compressor and the condenser in the engine room or a generator room to get the noise away from the cabin. And then refrigerant lines are ran through the boat to the evaporator, which is going to be located in each cabin. So in this case, your evaporator and your metering device are on the air handler, and then the other 2 components are located in the engine room. And the benefit of this is, again, not as much noise in the space, but the disadvantage is if you lose, your compressor for your master stateroom, that room no longer has any air conditioning.
Oh, I see.
Whereas with chilled water, which is the next thing we're going to talk about, you could lose a compressor and still have some redundancy built in. So this is going to be for, again, your boat's 50 to 75, 80 feet. And then the chilled water system is more of the 80 feet and above. You'll have, this is more of a hydronic system. So what that means is instead of sending refrigerant throughout the boat, we're going to send chilled water throughout the boat.
Okay. What's the benefit of that?
So the benefit of that is you can have, let's say, 2 or 3 of these chillers in the engine room, and all 3 chillers are working on cooling the same chilled water loop. They're working together as a team.
Okay.
The chilled water gets circulated through the boat, and then there's some redundancy built in. So if, let's say, compressor number 1 fails, compressor number 2 and 3 are still continuing to cool the loop. the master stateroom is still getting air conditioning.
Gotcha.
Yeah.
So there could be 2 or 3 of these on a single
could be
boat.
4. Yeah.
Okay.
Yeah. Exactly.
What would you say the average is per boat?
I would say 3 or 4. It's
Okay.
pretty common. Yeah. We like to size it so that you could lose a full chiller for maintenance or failure and still have enough capacity to cool the boat.
Okay. And is this the new most popular system out
Yeah,
there?
it is. So one of the things that's nice about the new systems is they're all using titanium condensers now versus what was formerly used, which is copper nickel. So it's 2 different types of metal. And remember, the condenser is where the seawater is passing through.
Right.
So copper nickel was a good material. It just is more susceptible to erosion and premature failure. So when the copper nickel fails, the refrigerant would leak out, and then seawater would get into the chiller, and the entire chiller would be trashed.
Okay.
So it was a big expense, big inconvenience. And so now a lot of the manufacturers are using titanium condenser coils, and they're extremely resilient and to seawater, as you can imagine.
What would you say the average maintenance or lifeline of one of these systems would be like?
I would say previously 5 to 10 years with copper nickel. Titanium has been out about 3 years, 4 years now.
Okay.
So we're probably going to see some chillers lasting 15, 20 years.
Oh, wow.
Yeah.
That's great. And with that, I'm sure, comes regular maintenance?
Correct. Yeah. So it is still going to have seawater growth and scaling.
Sure.
So every 6 months, we're recommending to flush out the condensers with an acid, a mild acid, to remove any growth in the chiller.
Okay. And then do you have to take this whole unit out of the boat to do that?
No, you don't. You would just disconnect the seawater connections, and then connect your descaling kit to the condenser that way.
Okay.
And then there's also some other maintenance that I would say is more weekly. Cleaning the sea strainer to make sure there's good seawater flow going through the system. Checking hose clamps for any loose connections. In the chilled water loop, remember there's a second loop of water going through the boat. It's a freshwater loop. We just want to make sure there's a glycol mixture in that loop to protect the chiller.
Okay. And what does that do?
So the glycol prevents spot freezing, because remember our evaporators here, we've got very cold refrigerant here, and then we've got water flowing past it. If the water flow is obstructed, it could slow down and you could get spot freezing of the water.
Oh, okay.
Which could escalate to a domino effect.
Okay.
And we don't want to see that, because then the water freezes, it expands, and then this cracks. So
Gotcha.
That's why we like to see glycol in the loop, in the
Okay.
chilled water loop.
Okay, great. I'd love to see units that you've pulled off of boats. I think you have some.
Yeah, we
on the
do.
other side.
We have some systems that just came off a boat. We could show you some air handlers and some chillers that just came off a boat that are getting replaced.
Okay, let's go
All
take
right?
a look.
All right, very good.
All right, so where are we now?
So now we're in the Elite Marine shop. This is equipment we just pulled off a boat. We're getting ready to refit the equipment. The equipment has reached its economical lifespan, and we're putting brand new equipment in the boat.
Okay, so what kind of systems are these?
So this is that third type of system, which is the chilled water type of system. So in this case, we had 3 chillers in the engine room. They were all working together to recirculate a chilled water loop through the boat. That chilled water loop was going to about, I think, 14 air handlers. There's some more over here as well.
Wow.
But here's a couple examples of the air handlers. So the water was actually traveling through this air handler. When the control inside of the cabin decided it needed to cool the cabin space down, it'll open this valve, let some chilled water through the coil. That allows this blower to pass air across the coil, absorb some heat from the water, absorb some heat out of the air into the water, and then the water goes back to the chiller plant. So all 3 of these chillers would then see that water, and it would absorb that heat out of the water, put it into the condenser coil via the refrigerant, and then overboard.
Wow.
Yeah, lots of moving parts here. Yeah.
A lot of moving parts, and I'm still trying to grasp this. So let's break it down a little bit more piece by
Okay,
piece.
let's go back to the refrigerant circle.
Let's do that. So what exactly is the refrigerant itself?
So the refrigerant is a chemical that has a pressure-temperature relationship. So
Okay.
at any given pressure, there's a guaranteed temperature that the refrigerant will be. So inside of this refrigeration circuit, there's no air, there's no water, there's no moisture, it's just refrigerant. And what the compressor is doing is it's just recirculating that refrigerant through those 4 major components. And what we're trying to do is absorb heat from the evaporator, which in this case is here, and then shed the heat into the condenser, which is here, going overboard. That's where the seawater comes in.
Okay, so the refrigerant is a chemical. I've heard of like Freon. Is that?
Yeah, Freon was a brand name, but yeah, it became sort of the Kleenex of refrigerant. So
Okay.
yeah, it was a brand name for R12, which is no longer in use. But yeah, Freon's a common way to describe refrigerant.
Okay, so it's just a chemical that is cold?
Well, it's not cold until it gets compressed.
I see.
And then goes to the metering device, and that metering device changes its temperature, or pressure rather, and therefore the temperature drops.
Okay, so it's
Yeah.
a process.
Yeah. So that refrigerant, let's say there's 1 pound, or let's say 24 ounces or 16 ounces of refrigerant fluid inside this system. It recirculates for 10, 15 years, however long this chiller lasts.
Oh wow, okay.
Assuming
That
it
was
doesn't
going to be my
leak out.
next question.
Yeah,
if you need
it's the same refrigerant going back and forth.
Okay,
yeah.
so you can reuse it, unlike coolant and
Right,
car or something
right.
like that.
Because it's not exposed to the atmosphere like coolant and so forth. That
Okay.
it's locked in here, assuming there's no leaks, which we don't want.
Sure.
Yeah.
Okay, so it doesn't like expire or evaporate or anything?
Nope.
Okay, very cool.
In fact, there's also oil inside of the compressors, just like there's oil in your engine.
Mm-hmm.
However, oil in your engine will get dirty because it's got combustion and outside air coming in and out, whereas
Right.
this refrigerant circuit has no outside air coming in or out. In a perfect world.
In a
Yeah,
perfect world. And then what if there is? Then we
If
have
there
problems?
is, so let's say the condenser coil ruptures and seawater gets in, then we have to totally flush out the whole refrigerant circuit. We can't have any air, moisture, non-condensables in that system.
Okay.
It has to be just purely refrigerant.
Okay, so is that what happened in these systems?
Yeah, one of these 3 systems I think had a rupture. The boat's going through an extensive refit right now. They're reconfiguring the location of the chillers and the space available to it. And we're also adding additional air handlers to the boat to provide more cooling in different spots of the boat, which is going to require more capacity, and therefore we're going to need more chiller capacity. So.
All right.
Yeah.
And then what are these units right here?
So these are old pumps that came off the boat. One was circulating chilled water through that chilled water loop, and then the other was circulating seawater, drawing it out from underneath the boat, sending it through the condensers in the engine room and the chillers, and then back overboard.
Okay, so this one was the seawater.
Yeah.
And this one wasn't.
Correct.
Okay.
This was the chilled water, yeah.
Yeah, you can see the difference in corrosion
Yeah.
there.
Mm-hmm.
All right, what else have we got
And then
today?
the other thing I was going to talk to you about is how could we have prevented some of these air handlers from getting moldy and so forth. So if you take a look at the inside of some of these, there's lots of mold and dust inside of it. And one of the ways we could have prevented that from happening is using better air filtration, which is something like this. It's got 2 layers, collects a lot more dust. And mold, dust is a food source for mold, and so we want to eliminate that. The other thing mold really enjoys is humidity. So the more humidity inside of a boat, I don't know if you've ever been in a boat and it smelled a little bit musty or moldy.
Yeah.
That's because probably the humidity level of the boat is high. So what I always recommend is customers buy an inexpensive hygrometer. I think this one was $20 on Amazon. You put it in a couple spaces in the boat and it'll show you the moisture level. of the cabin.
Oh, so it's 49% humid in here?
Yeah, correct.
Okay.
Yep.
Interesting.
And so what we want to see to prevent mold is anything less than 60%.
Okay.
Yeah. So mold, like I said, they love dust. It loves dust and it loves moisture.
Okay.
So between filtration and moisture control, we can keep it under control. One of the ways that we keep the moisture down is a couple different ways. The customer could go and buy standard dehumidifiers. They're kind of bulky and ugly. The other way is we now have new controls that we can install in each cabin. And what the controls do is they will actually, as they're cooling, they will pulse the heat strip inside the air handlers. And what that does is it actually keeps the cooling process lasting longer, which brings even more moisture out of the air, which then in turn keeps that moisture level below 60%.
Okay, so 60% is the sweet spot that we want to stay below.
Below, correct.
Okay.
Yep, absolutely.
Gotcha.
Yep.
Now, what happens if we see something above 60?
Above 60 for a long time, you're gonna start to see you're gonna have odors. You're gonna have mold begin to form, and once it gets in these air handlers, it's very difficult to get back out. A lot of times the air handler would have to come off the boat,
Like it is now.
Yeah.
Okay.
And then be mechanically cleaned, which is a messy process and labor intensive.
So is that what all of these units are
In
going
this
through
case,
now?
because of the age and the fact that we want to put new air handlers with the heat strips integrated, because we're putting the new controls in to keep that moisture level, it was more economical to replace them. Additionally, there's an option to have a built-in UV light. And so this customer wants the built-in UV light. They want the integrated heat so they could do the moisture control. And so therefore it was just more practical to replace them in this case.
Okay.
These were about 10 years old, which they could last longer, but like I said, with all the options, it just didn't make sense.
Okay, interesting. So now you mentioned the musty or kind of like humid smell when you walk into an older boat. Is there a way to get rid of that once it's already there, or at that point is it kind of too far gone?
Yeah, going and attacking that moisture right away would be good. And then finding the areas where you did get some growth and unfortunately cleaning them is really the only way to deal with it.
Okay.
Yeah.
Sure. So some tips for brokers, I would say probably buy one of these.
Yeah. I mean, buy one of these. If the boat doesn't have the integrated moisture control, try to hide some dehumidifiers just to keep that moisture level down. If the unit has the reusable, washable air filters in them, yank those out and put some good filters in. This has carbon in there, so that helps with the smell as well.
Okay.
Yeah. But you want a filter that's going to capture the dust, and unfortunately, filters that capture dust have to be thrown away, just like in your house. You can't wash out your house filter. So, you're going to want a nice filter and some moisture control right away if you have that happen.
So these are the good filters that you suggest?
Yeah. These are called carbonate. Again, it's got a MERV 8 rated filter media on it, and then there's also some carbon as well to help with the odors.
Great.
And I think these are made to fit in pretty much every size air handler. So for example, this one I think fits easily in there.
Oh, I see.
And then if you have them changed once a month, they're going to help protect the air handler and the boat.
Okay, so you would need one of those for each
Correct.
one
Yep.
of these. Does that get expensive, or are they relatively not that
They're
expensive?
they're about on par with your residential filters.
Okay.
Yeah.
Okay. Do you have any other tips for brokers?
The other tips I would say is just keeping an eye on that seawater circuit, making sure the strainer's getting cleaned, and having the annual or semi-annual maintenance done on the condensers, and it's going to make the system work a whole lot better.
Okay, great. Well,
All
thank
right.
you, Ben. Do you
No
have
problem.
any other final words for us?
That's it.
All right. Well,
All
thank
right.
you very much.
No problem.
I appreciate
All right.
the crash course on air conditioning.
Thank you.
Thank you.
Florida Nautical Surveyors is your complete solution to all your vessel surveying needs. Our team of seasoned experts, led by Malcolm Elliott, are the go-to solution for pre-purchase, insurance, or valuation surveys. Whether your vessel is steel, aluminum, fiberglass, wood, or even ferro cement, our surveyors have the knowledge and training to meet all of your surveying needs. Call Florida Nautical Surveyors today at 954-801-2140. Or for more information, go to floриданauticalsurveyors.com.
Our industry has learned that to control your data is to control your destiny. Yachtbroker.org is the key to that control. As a member of any professional yachting association, when you input your data, you are the owner of that information. At Yachtbroker.org, you can keep track of all data reports related to your company by viewing your customized live management dashboard. Create an eye-catching photo gallery with our new thumbnail editor. Follow vessels of your liking to get status notifications in current time. Identify special commission conditions immediately, and even report a vessel to our team and the listing broker. Need to have access to your fleet on the go? Yachtbroker.org is completely mobile optimized, so you can view and edit your listings from anywhere in the world. For more information on how you can get started using Yachtbroker.org, give us a call at 954-522-9270 or email me at casey@iyba.org.
Marine Professionals MPI has been in business since 1997. With over 20 years of experience, we at MPI provide you the very best in marine electronics, audio, video, and networking. We specialize in boats from 40 to 120 feet. If you need navigation, including Garmin, Raymarine, or any other top brands, MPI is your go-to source. If you need audio video equipment, MPI can provide you with HD TV and the very best sound with a Sonos hi-fi sound system. MPI is the only Marine Gold Sonos dealer in the country. Nowadays, everybody wants high-speed internet. MPI can offer you different solutions that fit your needs. Whether it's to pick up the marina Wi-Fi, cellular, or satellite, MPI has you covered. We'll make sure you can binge watch your favorite Netflix episodes anywhere, anytime you want. You can check us out online at marineprofessionals.com or call us today. I'm Mark Carreri, and I approve this message.
At Murray Ventilation Products, we bring over 20 years of experience providing ventilation and air filtration solutions. MVP is your most valuable player in demisters, intake and exhaust fans, and computer-controlled safety systems. We are well equipped to provide end-to-end solutions for OEMs and refit projects the world over. Call Murray Ventilation Products today at 772-631-2229.
Maritime arbitration has been around for hundreds of years. Now we have a new forum to solve our disputes. The IYVA has created the International Yacht Arbitration Council to solve our disagreements. We have experienced maritime attorneys and yacht brokers to serve on our panels, people who know the law, who know boats, and who know the yacht business. IYAC arbitration can handle yacht claims, contract, purchase, and commission disputes privately, quickly, and less costly than going to court. Sometimes disputes happen, and when they do, the IYAC is here to help you solve them.
Lauderdale Marine Center, a yard above.
Okay, folks, that's going to wrap it up for day 3. We've done AME with vibration analysis. We did Mike Murray's Murray ventilation products for air inlet filtration, and we learned about HVAC today as well. We'll be back tomorrow, Heather, 9 o'clock till 10:30 for day 4 of Yacht Engineering Week 2021.
Yacht Engineering Week 2021 has been made possible by Pantropic Power, the only authorized Caterpillar Power Systems dealer in South Florida. Florida Nautical Surveyors, your complete solution to all of your vessel surveying needs. And Robert Allen Law, exclusively dealing with the business of yachting. We would also like to thank Quantum Stabilizers, AME Solutions, DeAngelo Exhaust, MPI Marine Professionals Incorporated, Concord Marine Electronics, Lauderdale Marine Center, Marine Data, Isotropic, Dockmate, and Murray Ventilation Products. Thanks for joining us. See you tomorrow.